All right. Happy Wednesday, everyone. Did you know today is Global Recycling Day? It is. And I just wanted you to know that I recycle all my Word documents when I'm done using them. It's spring. That means allergy season for some people. But luckily, today's webinar is all about wellness, indoor air quality, and the OASYS House Case Study. What is the OASYS House, you ask? Why, it's Panasonic's OASYS Concept Home, which is a real-world case study. It's going to allow Panasonic, and by extension, all of us here, to explore how integrated whole home systems can improve indoor air quality, manage humidity, enhance comfort, and create lasting value. Here to give a brief presentation and then discuss the project further is Ken Nelson. Ken is responsible for setting the vision and messaging for Panasonic's wholesale business and developing the strategic initiatives that grow the company's market share among its valued distributor, specification, and contractor partners. With over 35 years of experience in wholesale distribution, including the past 14 years focused on ventilation and HVAC with Panasonic, Ken brings a deep understanding of the sales landscape from manufacturing to end user. Now, he'll be joined by Curtis Lawson. Curtis is the principal and visionary of Crafted Custom Homes, a Houston-based custom home builder and remodeling firm he has led since 2004. With more than 2 decades in residential construction, Curtis is known for combining real-world job site experience with a practical, systems-driven approach to delivering high-quality projects and better client outcomes. Now, joining us after their presentation to facilitate a group discussion is Sara Gutterman, co-founder and CEO of Green Building Media. Sara has established a reputation as a visionary thought leader and passionate advocate for sustainability, and she works closely with a diverse group of stakeholders in the building industry, such as our guests here, to develop impactful, long-term green strategies that are simultaneously sustainable and profitable. Now, our webinar is brought to you today by Panasonic. Panasonic Healthy Indoor Living Solutions is helping builders across the country differentiate themselves with powerful, code-compliant, and cost-effective indoor air quality solutions that provide a safer environment for homebuyers. During the course of the presentation and the discussion, you can submit questions for our panel. Simply use the Q&A function located in the menu bar at the bottom of the Zoom window. I'll review those questions and pose them to our guests after their discussion. All right, Ken, I'm going to go ahead and let you kick things off.
Mike, if you could a quick sound check to make sure it sounds okay. I saw a comment pop up that there might have been some echoing, and I want to make sure that we're crystal clear.
Okay.
So, but
I can hear you just fine, sir.
super, thank you much. So to kick off the story, two things. One is excellent that you're recycling, as I'm from the Pacific Northwest, where we grow a lot of paper products, paper trees. And so anytime that you can recycle and reuse that, that's a great boon for our forest industry. And two, I think it's exciting that we're talking about indoor air here today, as I'm in San Antonio. And one of the challenges they're having just today is that the pollen counts are obnoxious here in San Antonio, all across Texas. It's a huge pollen time frame where indoor air quality is really both problematic and fragile because of air pressure moving through the house, bringing moisture, bringing particulates, and the occupants struggling. So the OASYS house, the concept of the OASYS house is that it's going to provide a safe space, an oasis, if you will, for its occupants. By that, I mean it's going to provide indoor air quality. It's going to provide comfortable living environment, temperature controls, filtration. There's air purification in this particular application. It essentially becomes a safe haven for the occupants. And this is what we kind of strive for. And this is what all builders should be striving for, right? One of the biggest things that people look for in a home is they want to be safe and healthy. So, Mary, if you would advance the slide, let's talk about the OASYS project. So the OASYS project uses a unique HVAC strategy. I should say it's unique here in the United States. It's not so unique in Asia, where we sell or install a ton of the OASYS style applications, where in this particular case, what we're doing is we're using a singular air handler room. And then into that air handler room, the return air comes right into the room. And then we distribute that air after it's tempered, and it has a little MERV 6 filter to manage indoor dust and whatnot. and then it's, again, distributed throughout the house. We're using a couple of pretty dynamic features. We're using our exhaust fans as supply fans, which is an interesting, and I'll tell you more about that in a minute. But we're also using mini splits for moisture management, for temperature control, and then we're using ERV for fresh air or ventilation applications. So if you could advance that slide real quick. One of the things you'll see here is how the air flows throughout our house, right? We distribute it out of the air handler room. It pressurizes into the external spaces. That pressurization actually drives that return air back up into a larger space, which then goes into the air handler room where it's all conditioned and tempered and then redistributed. The objective of that is that we're going to distribute air throughout that house about it's 3.7 times, but about 4 times per hour. Every cubic foot of air in that house will cycle through that air handler room. So in particular, in the air handler room with our mini splits, we're also using our Nano E technology, which is a purification strategy within the ductless heat pump. It uses a hydroxyl radical to help manage viruses and bacteria, live viruses, live bacteria, before it can be redistributed back out throughout the system. So if you can go to the next slide. So what it does for the house is it allows for continuous and balanced temperature, humidity throughout the house. I've got a couple of slides here. These are little dashboard snapshots that we use to monitor the house itself. And on the left, you'll see in this particular snapshot, the outside was 30 degrees at 87% humidity, but 12 parts per million, if you will. So which is in kind of a high ppm 2.5 count, which is problematic outside, right? That just means there's a lot of bad air outside. As you look through the house, where it comes into the house through the ERV, and I'm sorry, my screen is really small. So it's going to come into that house. It looks like it's coming in around 3 parts per million into that, what we call that loft area on the right-hand side. You'll see an area, a dot that says loft. That loft area is coming in at 3.5, which is pretty remarkable. And that's the ERV. The ERV, the MERV 13 filter, is filtering out the particulates from outside before it allows it to come inside. And that way we can provide a particulate pollen. In this case, there's a lot of benzene. There's all sorts of stuff outside that comes in from different spaces, including their petroleum products that they manufacture outside of Houston and the Galveston area. So, but you'll also see the room temperatures are all within 1 or 2 degrees. So how we do that is we have direct path. Each fan has a direct path to that space that it's being distributed to. In some spaces, you'll have more than one fan. For example, that living room has, I think, 5 fans. The dining room has 1 fan. The den has 1 fan. There's a master bedroom that has 2 fans. But all of these fans combine to move 100 CFM continuously. So every cubic foot of space in that house gets changed out about 4 times an hour. So if you could go to the next slide real quick. That's a particular slide we just saw was a 30-degree outdoor. So here's an 85-degree outdoor, 73%. And you'll see that PM 2.5 outside is obnoxious. But when you look throughout the house, the temperature in the house is around 73, 74 degrees. What I go to look for is where the air handler room is, and you'll see the air handler room is around 66 degrees, 58%. So that air handler room is where all the cooling is occurring, and then it's being distributed. And this is at 1:23 in the afternoon. So this is the high part of the day, the hot part of the day. So we're actually able to manage that temperature to all the rooms and humidity. And we're going to go to the next slide, which will show us. Let's go ahead and move to the next slide real quick. Let's talk about that ERV for a second and how it manages heat as well as cooling. And we all know that ERVs were real popular in the northern climates for retaining heat into the house. But what does a ERV do when it's super hot outside? So this slide was done we tested one of our IntelliBalance ERV products in Phoenix, Arizona with Construction Instruction, who many of you will know is a great test and training facility in Denver. But they were at the time in Phoenix, and the outdoor temperature in Phoenix was 104.69 degrees. And these, just to be clear, these are measured at the nozzles of the ERV. So outdoor temperature coming into the ERV was 104.69 degrees. Room temperature of where the ERV was 71 degrees. But the air temperature coming out of the ERV was only 75 degrees. So your air conditioning only had to pick up 3 degrees of ventilation temperature, of ventilation air temperature. It was rejecting 91.78 degrees. So in this way, what we wind up with is we don't have an obnoxious ventilation, heating, and cooling load. And that's a beautiful thing because we can control the indoor temperature. We can throw money at the indoor temperature. We can add more AC. We can add more heat. We can do all sorts of things. But outdoor, and we still have to have our ventilation from the outdoor air. How do we manage that? The ERV will do that. For literally, at that particular value, it's probably less than 50 watts of energy to bring that kind of air conditioning mitigation into that space, which your air conditioner would not be happy trying to resolve. Basically, what is that, a 30-degree delta? Your air conditioner would be outside the bandwidth of your air conditioner to be able to provide demand temperature at that rate. So Mary, if we could move to the next one. So this is another example that we did in the house in Houston where the ERV, the outdoor temperature was 73 degrees, the indoor temperature was 73 degrees. And this is a big problem when there's no call for air conditioning. So how do we determine that the ERV is actually helping out? Well, if I look at this, the outdoor temperature at 73 degrees was 87% humidity. The indoor temperature at 73 degrees after passing through the ERV was 57%. So this, we see things like this and then we're like, oh, okay. So we need to go and look closer at this. So, because that's a big difference, right? We're knocking or rejecting 30% of that humidity at that value. Let's go look at some other numbers to make sure that that's a validated result. So if we could advance, Mary. So, okay, here's a cold temperature. It's 28 degrees outside, 68 degrees inside. The return air is 68 degrees. Excuse me. The return air is 61 degrees, and then the air from the house to the ERV is 68 degrees. So we're literally only having to reheat that air by 7 degrees, right? It's a big difference for a heating and cooling load. Let's go to the next one because I think the next one has that moisture management. Yeah, here we go. 71 degrees outside, 71 degrees inside, or 70 degrees inside, 83% outside, 55% inside. So when that 83% humidity comes in and passes through the ERV, it's only coming out of the ERV at 59%. So at 59%, my dew point is 56 degrees, right? At 80%, 83%, my dew point is 65 degrees. And honestly, one of the big goals in all of this testing is we want to make sure that no air enters the house above 60% humidity, because at 60% humidity, the dew point is high enough where it can phase change to water on surfaces like toilets, tubs, appliances, metal surfaces, anywhere where during the course of the day, the air conditioning is blown on that and chilled that area. Now, when that temperature starts to mitigate and there's no more air conditioning, that area, that mass temperature is below dew point or has the potential to be below dew point. Water will phase change there and become a problem. So we have to keep that dew point down based on humidity and temperature coming into the house. Go ahead and advance the slide. So in particular in the house, this is another weekly chart that we saw where there's your high temperatures, where the outdoor temperature is blowing up. And you can see that daily cycle where the temperature is going high and low. And the OASYS system, each line in that bottom, and I apologize because they're a little cluttered, but each line in that bottom represents a room in the house. And you can see the room average is around 72 degrees. Basically, it's a 3.6 degree Fahrenheit change or range between all the rooms throughout the house. And that includes the big picture windows in the great room, the smaller windows in the bedroom. So the objective here is that the house or the system manages all of that with a minimized airflow, minimized energy load. Let's go ahead and advance the slide one more time. So here you can see, again, it's kind of the same data chart, but we're looking at average temperatures for the week, 85 to 88 to 90 degrees, average indoor temperatures. And these are throughout the 24-hour period, the 73, 73, 73.2. And then you'll see that humidity load blowing up. And then I can't really tell from my visual here, but it winds up basically the outside humidity where it's up high at temperatures, it goes down low. The humidity in the house is going to stay really consistent. And that's what it's all about, is providing a living space that is safe, and it's not going to create a mold hazard. It's going to be a healthy indoor environment. So I think there's another slide, Mary. So this is another day where the temperatures were all over the place. Excuse me, I said a day, but another week where the temperatures were all over the place. And you can see it's all the way up to 91 degrees with outside humidity bouncing way up during the lower temperature days. But in the house, it's all very, very consistent, and nothing is going above 60%. And that's really is our goal. We want to make sure that 60% value stays below 60% on the indoor humidity. Okay, one more. There we go. And then just another chart telling us the same story. Essentially, this is room by room by room. So a lot of great data coming from this. And it's the positive side is it's all consistent. For week after week after week, it's been consistent. So let's move to the next slide if we could. So a couple of quick questions, typically reaches stable comfort conditions within. It depends on what's going on outside, right? Or how much outside. One of the upside downside is I'll tell you, it's not a super fast change of 5 to 6 degrees. It won't do it super fast. It will move predictably, but it won't move super fast. Is it an easy install? It's an absolute easy install. And then where do you put the air handler room? We have designs for it on end to end of the structure. We have designs for it in the attic space. We have designs for it in a basement space. It just really doesn't matter. We can, whatever your design is, we can adapt pretty easily, quite frankly. And then how does Panasonic integrate into this package? What we're going to do is, first of all, the house has certain criteria to be qualified as a OASYS type project, right? We want the house to have a great envelope, and the envelope is important because if it's a leaky envelope, the ductless heat pumps won't be your friend. You'll have so much moisture coming in at random spaces that it won't be controllable. It's like any other house, though. And that way, it's really no different. If you have a high performance product in a leaky house, it's not going to be high performance, because high performance really means it's going to work really well around the shoulders. If it has to go full blast, that's not a high performance pathway. So I think that might be the last slide. So, and I want to get to the questions because Sarah's got some great questions about the health of the house and the occupants inside, and I really want to talk about those as well.
Wonderful. Well, Ken, thank you so much. It's always fascinating to hear you talk about the OASYS project. Curtis, I think I actually want to start with some questions for you, since you are the builder of the OASYS house and obviously collaborated very closely with Ken and the entire Panasonic team. Let me start just with the fact that through our Cognition Smart data, we started seeing, even before the pandemic, a pretty dramatic increase in interest in health and wellness in the home. And of course, that spiked during the pandemic, and it hasn't really gone backwards since, the interest and awareness about health and wellness. In fact, if anything, I think it's just really becoming a baseline expectation. But consumers don't really talk about health and wellness per se. What they really notice is comfort and freshness. Maybe humidity balance can, maybe they don't talk about it exactly the way that you do, but they understand what that means, how it makes them feel, and also, I think, how quiet a home can be with, the right system. So, Curtis, how should builders and other building professionals start thinking about comfort, health, and sustainability as an integrated experience rather than separate features to really match this exploding interest about wellness in the home?
Yeah, I think first of all that like traditionally builders have thought more about like energy efficiency. That's always one of the first questions I get from builders is, well, is it efficient? Whereas when I talk to homeowners, that's not really the question that I get. So I kind of think there might be a disconnect there with builders, kind of what we as builders think people want and what people really do want. So that's my first point. But yeah, so comfort and wellness, it's more than about just temperature, right? I mean, as you mentioned, comfort is it's noise, it's humidity level, it's how clean the air is. It's all these things, and so um, that's one of the fascinating things I think about the Oasis system. You know, Oasis is not just a product. It's not just an air conditioning unit. It's a system. It's a way of managing all these things at once, right? So through the ERV, and to me, the ERV is the heart of the system, right? But through the ERV, we're managing so many things. You know, we're pre-filtering the air as it comes in. We're managing the humidity as it comes into the house. We're constantly exchanging the air. So one of the very first comments that I get from people when they walk into our concept home is, wow, this place just smells fresh. It smells clean. It feels comfortable. And you know, I can't say that I get that on other, you know, like open house events that I've had with other types of systems. It's like when they walk into the Oasis house, that's one of the first things they say is, it just feels and smells nice in here, right? So I think that that's something that people really notice and they really key in on. And I think that once people experience that, that they want to have that. So I think we as builders are doing sometimes people a disservice by focusing just on the energy efficiency portion. Because I think that, you know, obviously Oasis and the Panasonic products are efficient, but I think most products in the market today are efficient. There's no AC company that's advertising we're selling inefficient AC equipment in today's market, right? So really providing something to our buyers that our homeowners that feels different, that supports their health and wellness is super, super important. And the last thing I'll say on that is, especially when you have immunocompromised people or young children, elderly, those sorts of people really, really need better indoor air quality, and all these components that go into Oasis are even more important for those people.
Thanks, Curtis. I want to follow up with a question for you again. Many builders hesitate to adopt something that feels completely new, but one of the most interesting aspects of the Oasis concept is that it uses familiar technologies like vent fans, purification systems, mini splits, ERVs, just in an integrated and smarter way. So, why is innovation through integration more practical in this application than trying to introduce entirely new technologies? And, in other words, builders, if they're worried about complexity or cost or retraining trades when adopting new systems, from your perspective, how does this approach address some of those big concerns?
Yeah, I mean, I think that as builders, we're always nervous to introduce new things because, like you said, we have to train our trades. We're busy. We don't have time, and we're nervous about dropping something new on the trades and on our team, right? So anytime that we can use the off-the-shelf components that we're already familiar with, like most HVAC contractors and installers already know how to put in a mini split. A lot of them, if they don't know already, they've been learning recently, and it's becoming more common to install ERVs. So that's generally nothing new. Um, so yeah, I mean, using off-the-shelf components just makes us as builders more comfortable, It makes our installers more comfortable, and honestly, it makes our homeowners more comfortable as well because they're not seeing. I mean, other than ERVs, which are still newer to some homeowners, but we're not introducing some cosmic new thing that no one's ever heard of, and that also makes them feel better on the maintenance side, on the warranty side, and it makes us as builders feel better on that side as well, because we know when it comes time for service, for maintenance, replacement down the road, we're not having to find some really hard to find thing to swap out. So, um, but as far as like how all these things working together, I'm a really big proponent of the concept as a house as a system. Um, you know, I think for a long time, before houses were being built as tight as they are today, you could kind of interchangeably swap things out and not really worry about kind of how things interplayed. But with houses being built so tight, and with the kind of the stakes being so high on if something's done wrong, you really need to approach the house as a whole integrated system, right? Your building envelope, your ventilation, your AC strategy, everything kind of has to work together to set you up for success. And so I think that's why the Oasis concept is fantastic because it really addresses all of those things, right? Because for Oasis to exceed, we also need to succeed. We need to be building a high performance envelope, and then we're taking that, we're maximizing the performance of that envelope with a system with all these individual components that are designed to work together. I'm not sure if that answers your question, and maybe Ken has something to add to that as well.
No, that's great. And actually, let's riff on this concept of a house as a system. Ken, I've got a question for you. In traditional construction, the builder would often set goals for HVAC performance, but then hand off the project to a mechanical contractor who often chose or chooses the simplest installation path. But what changes when the mechanical system is actually designed up front with load calculations, airflow planning, duct routing, and commissioning guidelines that are already defined?
Yeah, that's a great question, right? Because what we're talking about is an outcome-based product rather than a convenient-based product for the installer. I mean, oftentimes installers will have a process that they've done in the past that's just unique to their material that the mechanicals they're installing. But what we're looking for now is an outcome and not necessarily um, an installer who's just done the same thing over and over and over for the last 100 years or who cares how long. But and that's what we run into. Well, I've never done it like this before. I've never done that before. And it takes a minute for them to understand that to get to the outcome that we want, which is not a mediocre outcome by any stretch, they're going to have to pay attention, right? They're going to have to make sure that the ducts aren't compromised in the insulation space. Make sure that the ducting isn't compromised at the fan assembly. Um, and yeah, we get a lot of contractors who just want to put in the lowest cost. And I got to be honest with you, one of the things that's important to me is that everybody has to make money in this project, right? It doesn't, none of us are community service people. We're here to make money. The more houses you build and the more you make money, the more houses you will build. And we need more housing in America, bar none. We need a lot more housing. So I need everyone to be successful. But it's not always the best route, the one we took 5 or 10 years ago. Times have changed, times are changing. And I think with the Oasis package, uh, it's a simple install. And for a contractor, once they embrace it, even the contractor who worked on the Oasis house, 2 days in, he's like, "Holy cow, I got this. This is easy. There's no big trunk lines. I don't have to go through any trusses. I don't have to modify trusses. I don't have to do anything. All I need is a GRD, a 6-inch duct, and the fans are all aligned. The builder's already aligned all the fans in a pathway that allows me to duct from point to point. So it's kind of getting away from your question, but it's about recognizing some new challenges and putting all that together and then learning how easily that can be done.
Thanks, Ken. Curtis, did you have something you wanted to add?
Yeah, I just wanted to say that you know the HVAC design part of this takes the guesswork away from the contractor, from the builder and the mechanical contractor. which is one of the key parts of the Oasis concept, is that our building performance designer is going to do some HVAC design. They're going to work with the Panasonic team to come up with all the duct layouts, all the equipment specs. So there's really no guesswork on the builder or the AC contractor side. It's basically just being able to follow instructions, right? It's really straightforward.
Thanks, Curtis. All right, Ken, I've got a question for you, and then Curtis, I'm going to come back to you. We've gotten a couple of questions from the audience about ERVs, so I'm going to weave my question about ERVs into a couple of questions from the audience, so this will be layered. So I want to talk specifically about ERVs because there's a lot of talk about them, but we find that some of our audience members and builders and building professionals still don't fully understand their role. So can you talk about what ERVs actually do for a home's indoor air quality and humidity balance, and then also talk about availability, because there were two questions about availability, because there seems to be some spotty distribution as well as contractor pricing.
So ERVs are my favorite topic, and that's really what I'm doing right now is I'm going coast to coast to talk about ERVs and why they're important. And the reason they're important is because, in our building world, ventilation air is critical. We have to have ventilation in a house. I want everyone to build a nice tight envelope, but when you build a nice tight envelope, ventilation air can be compromised without a mechanical process. So, and I talk about ventilation like every builder probably talks about their jobs, and that is, I want ventilation to be predictable and uneventful, right? I don't want to have to wait for a wind to blow. I don't want to have to wait for the temperature to be just right so I can open a window. I want it to be there every day, all night. So the ERV manages ventilation air. So your code's going to say, your standards are going to say, you're going to have 30, 60, 90, 100, whatever CFM of air continuously coming into your house. And that's where the ERV comes into effect. I can take that air, I filter it, I can dehumidify or humidify, depending on the climate zone and the temperatures indoor, outdoor. And I can basically get it to temperature within, think about a 90% efficient ERV, meaning that I have 70 degrees inside, 50 degrees outside, 90% of that 20-degree delta is 18 degrees. My heating and cooling system only has to move 2 degrees. So super efficient. And because it's part of the natural physics, we can do it for the price of running 2 ECM motored fans, less than 50 watts of energy, right? What is your air conditioning going to have to do, or your heating source going to have to do to try to make up that 20-degree delta? It's going to have to do a lot more than 50 watts of energy. So I can tell you that, and I just did this for a utility where we calculated the energy savings in climate zone 5, and it was $200 a year in energy savings in climate zone 5 at 4,500 heating degree days. It provided, $180 to $200 of energy savings over the course of the year. So it pays for itself in no time. The true challenge with ERVs is to help our occupants and or builders understand that there's also filtration involved, and that filter is going to get compromised and it has to be managed. So again, if you're doing a $200 savings, the cost of filters are pretty insignificant compared to that. And if you have compromised people within your house, those filters are going to be they're worth their weight in gold. So, and as far as finding product, I'm disappointed to hear that, because there are a lot of manufacturers who are producing ERVs. And I will tell you that, and I love our Panasonic ERVs, don't get me wrong. I think we make a great ERV. But I will tell you that the worst ERV on the market is far, far better than the best exhaust-only strategy or the best supply-only strategy. And there are a lot of ERVs on the market. We make some very, very good ones. And to a builder, I will tell the builder there's basically 4 things. Configuration, there's supply air pressure drop that I look for. There's the core, whether it's a cross flow or counterflow, and then there's sound, and then filtration. I guess that's five pillars. The sound, and all of those Panasonic really does hit on all cylinders in those applications. So if there's a problem in a specific market, if you could put that in the chat, I will find someone who can reach out to you, or I will reach out to you and tell you where you can source ERVs. But they should be readily available in all markets in the US and Canada.
Thanks, Ken. One more quick question, and then Curtis, I'm coming back to you. We've had a couple of questions about the application of this integrated system into retrofits. Can you talk about that a little bit, please?
So the OASYS is challenging in retrofits, right? Because we do have to add that air handler room. I'm not saying it's impossible. I'm just saying it's challenging. If you're doing a complete gut rehab, it's probably pretty darn easy. I will tell you, though, that it's going to start with your envelope. You're going to have to be able to, blower door test your envelope below 1.5 ACH to make it a truly an effective strategy. But yeah, we can do all sorts of interesting things, especially with like ADUs and DADUs, where I have these smaller footprints as well. We have currently projects on the books for multifamily where we're doing townhouse style applications. So there's a lot of ways to get there, but in a retrofit, I'm going to need clean walls and access to ducting, for access to a space, a mechanical space, a clean space, if you will, and distribution area.
Thanks, Ken. Curtis, can you talk with us about some of the lessons that you learned when you built the OASYS house? What surprised you most about how this system worked in real time and in the real world, and what you learned that might change how you will design homes in the future? And kind of the third layer of that is, I know that there were some actual people that lived in the house for a while, and talk a little bit about, please integrate their feedback into your response to this question.
Yeah. So I think what surprised me the most was one of the things that I mentioned a while ago was just kind of the comments that I got around how fresh and clean everything smelled. Um, I knew the system was going to be effective, but I wasn't kind of prepared for like the number of comments that I got around that. So that was fantastic. Um, Functionally, I've just been really impressed at how temperatures have been managed. I know Ken showed some slides a minute ago with some data. There's a lot of numbers on there, but the big picture is from in fact, the month after we commissioned the house and Panasonic took it over after we built it, we had like temperatures in the 20s with snow on the ground, which is super unusual here in Houston. And then a few months later, we had 105 degrees. And every time I went in the house, the temperature was super, consistent, even. It felt comfortable. Everything was regulated. So that was one really big surprise to me, was like how effectively it was handled from kind of the two temperature extremes, and then all the humidity fluctuations that we deal with here in Houston. So that was kind of a surprise. On the installation side, there was really no surprises. I mean, we kind of had a really good picture of what the installation was going to look like before we started, but as I mentioned, it's super easy to install. It's all, yeah, I would say the only a little bit tricky thing, and I don't think it's that tricky, was when you have in our case we had 27 transfer fans, which are essentially the Panasonic bathroom exhaust fans, but we're calling them transfer fans. But for people who are familiar with products, they're bath fans, right? We had 27 of those in one closet, and that meant 27 6-inch home runs coming into that closet. So there was a little bit of, making sure that we had space for all those ducts to run, to make sure the ducts didn't get crimped and bent and all that kind of stuff. That was the only thing that was a little bit challenging, was just making sure that we had those pathways there. But we had some great planning up front, so we knew it would work. But sometimes in the field, you have to make a few adjustments to make it happen. Um, as far as the occupants, they were Panasonic employees, so I'd have to let Ken probably speak to that a little bit more. I didn't always have direct contact with them, um, so Ken, you might want to chime in on what their experience was.
Yeah, and they're going to echo exactly what Curtis said about how comfortable the house was. And I always take, when it's a Panasonic employee, you got to take that with a little grain of salt because of their bias. But, even when I went in there, and I'll tell you right now, they were cross-cultural employees that were there who have different lifestyles and life expectancies and processes. The house was neutral. I mean, you're not smelling anything from the kids. You're not smelling anything from the kitchen. That part of it I thought was actually pretty remarkable because they did have a different cultural processes for cooking and cleaning and so forth. So it was kind of interesting there. But yeah, go ahead.
Uh, I was just going to say that also, so about the occupants, what Ken is beating around the bush at was they had a different kind of expectation on temperature range that's comfortable to them. And the country that they came from, they generally kept things a lot warmer than we do here in the U.S. inside the house. And so there was a lot of like, hey, we have some meetings here. Let's get this back down to kind of like normal U.S. temperatures. But for their comfort level, it was also very comfortable for them. And then when we had
Right.
events, when we had events at the house, we would drop the temperature back down to where we wanted it to be, and it was also very comfortable there as well. Um, Kind of the last thing that popped into my head was regarding noise. When you're talking about surprises, things that I was impressed or surprised about, you, when you have 27 fans that are running 24 hours a day, 7 days a week, plus two mini splits, plus a ERV. We also had a dehumidifier, which is not part of OASYS, but we also had a dehumidifier that we were doing some testing with as well. So we have a lot of equipment in the house running 24/7. There was virtually no noise in the house. I was really, really blown away by how quiet the system was. When you have a typical forced air system, when that outside unit kicks on and off, you have surges, you have a lot of noise, you have the rush of air moving, and overall the system was very, very quiet.
So to add on to that, not only did and to Curtis's chagrin, he built us a beautiful house. And then after he handed it over, here comes my guys putting in test and measurement devices. Every room has at least 3 to 9 test devices or sensors to measure temperature, humidity, PM 2.5, carbon dioxide. I don't even know all the other things that they're measuring there, but one of the things that we learned is even when we had large populations in the space, and we've been using it as meeting space, Curtis has used it with his Houston Home Builders Association, the greater bringing people in, and we monitor carbon dioxide loads, right? So literally, the carbon dioxide load has a ceiling of about 600 ppm, which is interesting because when you put some 20 people in there, there is the potential it could get really, really high. This is just a 2,700 square foot house. But because of the way the air change works, you never get this excessive concentration of carbon dioxide. So if you had kids, 2 or 3 kids, or you had the whole junior high football team over in one of the bedrooms, you would never see an obnoxious carbon dioxide load because you're exchanging that air 4 times an hour. So it's constantly flushed. And that was one of the things that we're learning is that with all these sensors and so forth, we don't get any problematic air pockets within the house, which is kind of remarkable. So there's a lot of things that we're truly learning, including about humidity and moisture and temperature within the house, and how surface temperatures can be modified or changed when you have air blowing on them and whatnot. So it's been kind of a fun adventure, if you will, from that respect.
So, Curtis, kind of going back up to a higher level, if a builder or building professional is interested in delivering healthy homes, but feels a little overwhelmed by the idea of changing their mechanical strategy, where should they start? What are your tips for success for them?
Yeah. I think you have to start with a great team, and that team needs to have a building performance consultant, a performance designer. I think this is a shift in thinking for a lot of builders, because we've got our architect or, house designer, interior designer, engineer, structural engineer, and we think that's generally our team, right? But nowadays, regardless whether it's OASYS or any mechanical strategy these days, with the way that we're building homes, how tight we're building homes, I think it's super important to have a building performance consultant as part of your team. And that's a couple $1,000s. And I realize a couple $1,000s is a big deal. It's money, but I see it as a layer of protection for me. It helps limit my liability. It also educates me every time we do it. But that building performance consultant is someone who's going to, at least the companies that we use, they're going to handle all the blower door testing. They're going to handle all the paperwork for the energy side of things, for permitting. They're going to help do inspections through the process. So there's a lot that we're getting for that money that we're spending with them. But having a performance consultant, I think, is the number one thing that you need to do. And they're also generally going to do some HVAC design. And in the case of OASYS, they are going to work with Panasonic, and Panasonic has specific people that they're partnering with as consultants for you for these projects for OASYS. But they're basically going to work with Panasonic to make sure that all the equipment specified properly, all the ducts are designed properly. They're going to come out after install. They're going to look at it. They're going to do some verification, make sure everything is done right. So, having that person or that company to provide that service, that's the most important thing in my opinion. And then beyond that, I think it's really important that you work with a manufacturer who's going to offer really good support. Obviously, I'm here with Ken, and we're talking about Panasonic stuff. Panasonic has a fantastic support team. They're really there for builders. Um, but there's a lot of other companies out there who also provide really good support. And that's something that I think that we as builders, especially kind of old school guys who've been doing this for a long time, um, AC aside, I think we don't lean on our vendor partners enough. There's so many resources out there for us, whether it's AC, plumbing, paint, flooring, whatever it is. All these companies have great manufacturer support if you'll just make the phone call, right? So in our case, even if this wasn't the Panasonic concept home, I call Ken all the time. I'm like, hey Ken, I've got this house that I'm working on. What do you think about this product or this design, right? So having a great manufacturer relationship, I think, is equally as important as having a great building performance consultant.
So, Curtis,
To
that's a really
kind of
nice dovetail into my next question, Ken, for you, which is, can you talk a little bit about Panasonic's builder certification and support program?
It's funny, I was just going to go there, right? So our builder program, we have a website where, and we are actively looking for builders who want to be a part of the program. So, but you would go to the website, you would review some of the criteria, because again, not all builders are going to be able to be successful with OASYS, right? It needs to be a builder who consciously um, wants to provide a high performance product for an occupant health. It's not just for an occupant health, but for an occupant comfort, uh, program that's going to continue to serve that occupants all down the line here, down in the next 20 years, if you will. So you would go to the OASYS website and go into the builder program. You'd sign in. We have a person who will give you a call. Um, Curtis talked about our MEP program. We would review your plans, talk about how we can fit the OASYS package into your design. Because really, what I don't want to do is I don't want to go to a builder and say, well, I'm gonna scramble your architectural process and change the way you build to satisfy my objectives with OASYS. So I want to be able to put my package in with your package and allow that builder to sell his brand, his uniqueness, and his quality. Um, so it's a pretty straight ahead process once you get started. And then we just integrate our team into yours, or into that builder's team.
Great. Thanks, Ken. So I've got one more question for both of you, and then I'm going to ask Mike to come back and ask a few more questions that audience members have posed. But let's talk about the future of health and wellness in the home. So first Curtis and then Ken, are there any wellness related either products and technologies or just general trends that you are watching, that you have your eyes keenly on, that we should all be paying attention to?
I've had a lot of customers over the last few years, and it's getting to be more and more really keying in on zero VOC. I think low VOC is pretty much the standard, but zero VOC is really what people are asking about. So I think that's a big thing. Um, and I think something that goes along with building tighter homes and getting uh, carbon monoxide out of the home is electrification. So looking more at obviously heat pump AC systems, but also induction ranges is a big thing that we've been talking about with customers over the last couple of years. Um, I would say that those two things are the biggest for me. So zero VOC and induction ranges, heat pump water heaters also.
hmm we're seeing all of those things trend as well. In fact, just a quick caveat, it's pretty funny because when we talk with our members of our consumer audience that are younger, say millennials, Gen Zs, even emerging alphas who will start buying homes in the next 4 to 5 years, the oldest alphas, when we talk about induction cooktops, their response is, why would I want to burn gas in my home? Right? That's gross. That makes homes blow up. They don't say, oh, they don't have the same mindset where cooking
Right.
with gas was, considered to be the luxury. So things have really changed pretty quickly generationally, certainly within that category. Ken, how would you respond to that question?
So one of the things that we're seeing is more like automated trigger programs, right? So do I have to turn a bath fan on? I mean, I had three girls that I raised, and none of them would turn a bath fan on. Whatever state that bathroom fan was in when they went in was what it was when they came out. If it was off, they would sit there with the blow dryer and clear the mirror, right? I mean, so automated triggers like condensation sensors to activate fans, CO2 sensors to activate from low speed to high speed on your ERVs or your whole house ventilation. We already have that with thermostats, right? We have a thermostat that's an automated sensor, so I don't have to go in, get cold, build a fire, or whatever. So we're seeing more and more of stuff like this. In the industry, from a federal standpoint, we're seeing more about fault detection, right?
Mm.
Listen, we want a bell to go off when it's not working. So we have those as well that we're looking into. Um, Also, more efficient ways to get distribution of fresh air. And again, filtration is important. I'll go back and one of the things I talk to builders all the time is about filtration because filtration, it has no value to bring air in if it's contaminated. But we talk a lot about how to move air within the house so that you don't have stagnant air in spaces like closets and even attic spaces. So we're seeing that kind of thing as well. But right now, I would say the big discussion is automated triggers.
Actually, I'm glad that you brought that up because proactive IAQ systems has for a long time been the number one response when we survey our consumer audience in terms of, their top priorities for indoor environment quality or healthy home upgrades. They want those systems that proactively can monitor and sense toxins and humidity
Sure.
and VOCs and pollen and other particulates in the air, and then turn on a vent fan or a range hood or run the ERV. Ken, actually, I want to ask you one more quick question because I get this a lot, and I want to hear you say this because I don't think I've ever asked you this question. And I want to make sure I'm answering it properly. What is the
Yeah.
difference between air purification and air filtration?
Well, certainly, filtration from a straight ahead perspective, filtration is just pushing air past a filter and basically capturing problematic components or particulates, right? It's just capturing that. And I'll come back to that in a second. Where purification is where once something gets in, and typically with purification, I'm talking about active virus or bacteria, something that's alive, right? And purification is a very difficult component in the residential industry because it's trying to kill something, right? Even though it's a virus or a bacterial piece, it's trying to kill that. So we have to be very careful how we do purification. And even in our nano E technology, the nano E is basically an energized hydrogen molecule that touches another hydrogen molecule, which is typically in a water molecule, right? Because hydrogen is 2 parts hydrogen, 1 part oxygen from water vapor. And that energized touches that and it gets a slight electrostatic shock. So anything that was alive, and bacteria have to be, and viruses have to have water vapor to stay alive. So that changes that bacteria that's in that water vapor. And that's all we do. There's ultraviolet light, which is somewhat problematic, right? We all know that we don't want to be taking on massive ultraviolet lights as humans. And the way we do it within that is it's all within the air handler room or within the ductless head, quite frankly. It never sees the human area, the space where people are living. But filtration is another thing, right? We also, it used to be we would never advocate putting a filter inside the house because why would you want to capture, particulates before they're exhausted out of the house? But in our case here, since we're recirculating so much air, we are putting MERV 6 filter curtains for dust, and we have a MERV 6 filter on the air conditioner head, the ductless head. And in other situations, you can increase that filtration process to help capture even more stuff. And I know, I'm in the Northwest, and as you remember, when you were in the Northwest, we got our wildfire season, which, that's a difficult time in a person's life during wildfire season because unlike pollens and stuff that affect certain people certain ways, wildfire smoke affects every creature that breathes air, right? Every creature, whether it's humans or pets, all that. So to manage wildfire smoke is a whole different animal. And we can mitigate some of that with our MERV 13s, but we also have the potential to add HEPA filters and so forth. So I'm a bigger proponent of filtration than I am of purification. But at the end of the day, I spend a lot of time talking about strategies for filtration. And I would encourage everyone to consider that.
Mm-hmm. Thank you, Ken. Yeah, the wildfire comments resonate with me. I'm at 9,000 feet in the Colorado
Yes,
Rockies,
that's right.
near Telluride, and we don't have AC. We don't have air conditioning. So in the summer, it gets up to maybe mid 70, and we just open our windows and have some
Right.
fans. So wildfire smoke is a big concern for
A
us
big
for a
concern.
lot of reasons. With that, Mike, I know you've got a couple more questions from the audience, so we may run over for a few minutes, but Ken and Curtis, thank you both for responding to my questions. I've found this fascinating. Mike, take it away.
All right. Thank you, Sarah. I wanted to pass along a couple more questions from our audience members. So this one goes to both of you because I'm not sure if this was applicable with the Oasis home or not. Jeff wanted to know, how well does this integrate with aero-sealed ductwork?
I think it integrates well. I mean, first of all, when we're transmitting temperature, air and temperature from the air handler room, we want a perfect duct system. We want the temperature in the air to come to the space where it's designed to go to. I don't want it to leak out in other places. So it's important that you have a complete ducted system, and that system has to be and quite frankly, it'll be tested. We're going to test the output of the fan, and we're going to test the output of that grill register diffuser, and they need to be within 2%, right, or less, because I don't want to just dump random air into some space and not get it where it needs to go. So I'm a big supporter of the AeroSeal program, certainly on the envelope, certainly on ducting. I think that everything that makes that envelope better is all good.
Okay. Curtis, any follow-up on that?
No, I agree. I think doing AeroSeal on the envelope in particular would be a great strategy. We didn't do it on this house. We got down to like 1.4 ACH without going there. We probably could have got sub one if we'd have done that, but 1.4 met our needs for what we're doing, and there's some diminishing returns past that.
Right. Okay, cool. So Michael asks an interesting question, not me, a different one. Why use a ductless heat pump with fans and then some other ducting versus a ducted say, cold climate heat pump air handler that's integrated with an ERV. You got a couple different choices there. Why go with one over the other?
Well, first of all, we like this system in Houston in particular because and we did two single zone 2-ton systems. But when we're talking about managing humidity in air conditioning, we want to pull all that moisture out, and we need space over the coils. And I could have done literally we could have got by with a 3-ton. I mean, that was well within the predictability of the temperature and whatnot. However, with two single zones, we were able to pull more moisture out of the air at less speed. So it worked out really well there. Plus, the Oasis house is it's, initially when we put this all together and in our generation 2 and generation 3 designs that are out that are in the future, you'll have solar and battery, right? And if I do two single zone systems in the same air handler room, I can literally have an environmental failure outside where there's no power, and now I could run one single unit and have environmental controls within the house. And again, it becomes a true safe space for the occupants. If you have a compromised occupant or a compromised family member, this Oasis project, you really need to take a hard look at this because this is designed to provide a safe space. And that's kind of what the name behind it, the Oasis. And to be clear, we could do it in a different process. I mean, it's not out of the wheelhouse. It's just this was the best strategy for the application that we were creating.
Yeah, so
Right.
I'll follow up. So I think one of the things that Ken mentioned about the ability to run one unit off of solar and battery is huge. They didn't mention that, but so far, but we did that on this house. We have a solar strategy on this house as well, solar and battery strategy, and able to run the system off of one unit. So that's part of it. But also just some redundancy for the event that one of the units were to go down. So we have two mini split units within the air handler room. If one of those units were to go offline, need repair, need to get replaced, whatever, the other unit is capable of operating the whole house. So you have a little backup there in case of maintenance or something breaking down.
Well, and you mentioned redundancy. I mean, given that you're talking about solar and battery, that also gives you redundancy in case of a power outage, correct?
Yep.
Right.
Yeah. Wanted to get to Aaron's question as well. Wanted to know if, Curtis, did you install an active or a passive radon mitigation system in this home?
We did not. We don't have a radon issue in our area at all, and it's not required, so we didn't do it. And honestly, I've been in Texas my whole life for the most part, and so we don't really have that issue here. Ken might be able to speak on to that and some other markets and how that might work.
Yeah, how does
So
that work? And does that throw anything off or not? Can you talk a little about mitigation systems? Because I live here in the Midwest, and it's not uncommon at all to see them in homes.
right.
So I'm just curious from a airflow and air handling perspective.
So your energy management group would go in and look at that. And what we would probably do in this particular case is we would seal that floor space. Remember, we're going to seal the envelope. You're still going to do an active, if not an active, a passive mitigation system in the the crawl space area, right, with your rock and your visqueen and your pipe out to the center of the house. All of that will be the same, but we would seal. We would probably do whether it's seal that floor somehow, some way, shape, or form, whether it's closed cell or something along those lines. In Houston, we did, and correct me if I'm wrong, because we have water that comes from the ground up, we did a closed cell flooring, insulation on the flooring, and then we did open cell in the attic space. So again, that's part of your MEP is going to look at your water, how things move through the house, and protect the house, protect the occupants based on that. And again, this is a comfort cost and safety cost that we build into the house. So it's all good.
Yeah, we're in the floodplain here in Houston, a lot of hurricanes and that kind of thing. So we're required to build the houses up out of the floodplain a certain number of inches. And so this house is built on I think it's 4 foot finished floor,
If I remember right. Yeah, it was a 4 foot brick.
4 feet off the ground. So we have a pretty good crawl space under the house. And so that was sealed with a closed cell foam. So, and we have a Stego vapor barrier on the ground with gravel. So it's similar to doing a radon mitigation
Right.
system, essentially.
Okay, awesome. Well, I don't see any other questions, gentlemen, so I am going to go ahead and wrap it up. But thank you so much for taking the time to be with us today, share this information, get after the audience's questions. We really do appreciate it.
Thank you.
Thank you, Mike. Thank you, Sarah. Mary, I appreciate your time today.
Yeah. Thanks to the audience. Again, thank you to Panasonic for their generous sponsorship of this webinar. Our next webinar is going to be in just 2 weeks. That's on April 1st, and that's no joke. We'll be back with another Housing 2.0 webinar featuring Sam Rashkin, and I might be there too. We'll be talking about the disconnect between offsite construction and affordability. We're going to get started at our normal time of 2 p.m. Eastern. Until next time, enjoy the beginning of March Madness this weekend, and stay safe, stay healthy, and take care, everyone. So long.
Good day.